Hi everyone, welcome back to the Microsoft in 29 days self-paced course. So just a quick reminder, in case if you have not registered for this course, so make sure to register for this course, because after you register and you click on the start button for this course, so you can see that various tracks days are present, like day 10, day 11, and every day is present here. And on each day you will get the recording for the video tutorial for the two problems that we do as classwork, and you'll also get 5 problems to solve, where 2 problems will be there that we solved in classwork, and other 3 problems that I give you as homework for each and every day. And you can also check your progress amongst your peers on the leaderboard. So make sure to check this course out in case if you haven't already. So let us discuss this problem, that is rearrange characters. So the problem has been asked in various companies, and it says that given a string s, so we'll be given a string s with repeated characters. Okay, so basically we'll be given a string which will have some repeated characters, and our task is to rearrange the characters in a string in such a way such that no two adjacent characters are the same. We have to rearrange the characters in such a way such that no two adjacent characters are the same, and the string has only lowercase characters given. So it can have multiple solutions. In that case, we can return any of them. So suppose if the string has been like a, b, b, and b. Okay, if this was the string, so I could rearrange it like a, b, such that no two adjacent are same. This could be one of the ways. Other way could be I could make it like ba, ba. Then also no adjacent character is the same. So that is what it is saying, that if there are multiple answers after rearrangement, so you can return any of the valid answer. Okay, this is one thing. Another thing to notice in this problem is, like, suppose that we had a, so this was possible. But suppose if we had a and b, okay, so in this case I can see that the size is 4, and can I place these characters? No, because if I see, there are 4 spaces for me, 4 places. I have a here, I can put a here, then I can put alternate a's at maximum. Then if I, let's say, put b here, then I have to put another a here. So that means the adjacent characters becomes the same. So in this case, I can observe that if the frequency, right, I can observe that if the frequency of a particular character, okay, so basically we can observe that we will be counting the frequency for each and every character, and if the frequency for a particular character, if it becomes greater than, okay, if it is greater than n by 2, in that case I can say that it's not possible, because you can see here, if the frequency becomes if the frequency is 2, then I can afford it, right? If it was just a b a double a b, I could afford it. But the moment the frequency becomes greater than n by 2, in that case I cannot afford. This is for the even cases, right? When the length is even. Let's suppose what will, like, let's see what will happen when the length will be odd. So let's think about a scenario when the length will be odd. Okay, so if we think about the scenarios when the length will be odd, so in that case what will happen? Suppose if we have a string like a and then bb, so here we can see that n is equal to 5. So is it possible for me? Let's try and see it. 1 2 3 4 and 5. So I'll have a here, I'll have another a here, I'll have another a here, okay, then I'll have b, and I'll have b here. Okay, so if we clearly observe in this particular case, so I'm able to do it. Okay, I'm able to do it. But in the earlier, we concluded that what if the frequency, we concluded that the frequency of the character, if it is greater than n by 2 in case of even, when n was even, then it was not valid. But will this be valid here also? Because, like, if according to me the frequency of a is 3, which I am able to place here, okay, out of the 5 characters, 3 characters are a, but I am able to place it properly such that no two adjacent characters are the same. So should I return a -1 here? No, because you can see the frequency of a is 3, and if I check for n by 2, so 5 by 2 in terms of integer is nothing but 2 only. So in this case I'll return -1, whereas actually the answer is possible. So for this case, I can observe one thing, that for the odd cases when the length is odd, I can say that it is nothing but n plus 1 by 2. Okay, n plus 1 by 2, because that will be nothing but 6 by 2. So if the frequency is greater than 3, in that case I cannot place any more a's, right? Because at most I can place 3 a's apart, like separate from each other. I can place 3 a's separate from each other, separated from each other. Other than this, if I place a, so they will collide. So basically adjacent characters will become the same. So I can say that n plus 1 by 2. But is it true for the other case as well? Like, I can say that for, you will say that for, okay, for even the frequency should be greater than n by 2, and for odd length string the frequency should be greater than n plus 1 by 2. But actually we can use n plus 1 by 2 for all the cases. Why? Because as if we look back at the even case, suppose if we look back at the case where a and b we had, So in this case, we cannot place it, right, when it is greater than n plus 1 by 2. So here n is what? N is nothing but 4. When I do a n plus 1, so that's nothing but 5. If I do 5 by 2, so that's nothing but what? It is nothing but 2 only. So in this case, I can say that in even also, I can say that if the frequency of a particular character is greater than n plus 1 by 2, in that case, I will return simply a -1 string, indicating that the answer is not possible. Otherwise, I'll rearrange the characters in such a way that the answer would be possible. Now, one more thing to understand in this particular problem is, suppose that we had several characters with us, okay? Suppose we had several characters. Suppose we had what? We had, let's say we had 4 A's with us, okay? Then let's say we had some B's, okay? Then let's say we had some C's as well, okay, like this. So what we could have done is, like, we could have placed A here, okay? And let's say we place all the 4 A's. Then we could have placed B here, another B here, another B here, okay? If we do it like that, then the 3 C's are left, okay? You can observe this. So in this case, actually the answer will be possible because no character is having the frequency greater than n plus 1 by 2. So the answer is possible. But if I arrange it in this manner, which is very non-optimal, so in that case, I'm getting a wrong answer because the adjacent characters become the same. So it is also very important for me to track that how do I actually place the adjacent characters. So for that, what I can do is, like you can see, observe every time. Like if I'll give you this case, right? If I'll give you this case, so you will always tell me that, okay, what we will try to do is we'll try to place, let's say A, B, and then C. So we'll always try to keep a track of the highest occurring characters, and then one by one we'll try to place them, okay? So for this, if I want to access, right, if I want to access, if let's say this was the case, suppose. So in, like, if suppose that a case of this kind was there, suppose we had 3 C's here, something like this, okay? So if I place A, okay, then I place B, A, B, then 3 C's are left here, you can observe. So I need to tackle this case. So I can say that every time whenever I insert some of the characters, so the frequency keeps on updating, and I should also shift myself according to that. I should keep myself updated according to it, okay? Because I want the 2 most frequent occurring characters at a certain point of time to insert into the final string. So I'll say that, okay, suppose that there was A, there was B, and there was a C. Okay, so what I could have done is I could have a data structure. First of all, I am having the frequency A is equal to 4, B is equal to 3, and C is equal to 3. So I need a data structure which can help me to get the 2 most frequent characters at one point of time. And I can say that if I want to get the most occurring character, most frequent character, so in that case, I can use what? Max heap. Max heap will help me to get the most occurring character, right? Most frequent character. It will help me to get this thing, okay? So what I will be doing here is, I'll simply say that I will have A is equal to, like A is equal to 4, B is equal to 3, C is equal to 3. So I'll take out the first 2 immediate characters, A is equal to 4 and B is equal to 3. When I take them out, so I'll pop them out of the priority queue, okay, one by one. And then I will say that, okay, I'll place I'll add A into the answer, then B, and their frequency would reduce by 1. Okay, if the frequencies are greater than 0, then I'll again place them. So again, now you can observe this, that now there is some updation, because if you will see here, so now B's frequency is 2, C's frequency is 3. So now instead of placing B's, now I'll have to place C. Okay, so up till now the answer is AB. So I'll place the two most frequent characters adjacent to each other, such that in the end I get a string where no 2 adjacent characters are the same. This is what I'm expecting from myself. So what I will do is I'll take A is equal to 3 out and C is equal to 3 out. Okay, then I'll place A and C. Then A's frequency would become 2, C's frequency will become 2. Okay, so I'll update A's frequency to 2 and B's frequency to 2 as well. Okay, then I can take any. So let's say I take A and B. So if I take A and B out, so in that case what will happen? A's frequency and B's frequency will change. So in this case, if I have to update it, so A's frequency will become 1, B's frequency would become 1. Okay, and C's frequency will be 2. Now I can say, like, if I place, like, you can understand, if I place suppose AB and then I have CC, so in that case I'll get a wrong answer. Like, you can understand if I did it normally. So that is why I need to take care of the frequent characters, right? The character with the higher frequency. Because if I place AB together, if I had placed AB together, then CC would have been left. But that is not something that I want. That is why I'll give priority to the higher characters. So let's say I have taken A is equal to 1 and B, like C is equal to 2 and A is equal to 1. So first of all, let's say I'll place C, then I'll place A. Okay, if I do that, so now A's frequency becomes 0, so I'll not insert it again, and C's frequency gets updated to 1. So I'll place, let's say, B and C here. So you can observe that I have made a string in which no adjacent characters are same, because the answer was valid here, and now the max heap would become empty. Okay, but they can be one. Like, will I only stop? Like, one thing that I have to notice is that for doing this operation, the max heap, right, the size of the max heap, okay, should always be greater than equal to 2. At least it should have 2 characters in the max heap, right? Along with the frequencies, I need to store them. But there's another thing that we need to observe here. Suppose if we had like A and then double A B we had, okay, suppose. So in this case, A is equal to 2 is having the frequency and B is equal to 1. In the max heap, I'm having this particular frequency, okay. So what I will do is, I will take out A is equal to 2 here and B is equal to 1 here. So I'll place one of the instances of A and then B. Okay, I'll update the frequencies. So A's frequency will become 0, like 1, and B's frequency will become 0. So B I'll never insert back again. Okay, so now you can see that I do not have 2 characters in the max heap. So I cannot take any character out, right? I'll stop taking out. But can I see that my string is still incomplete? Yes, because if just one element is left inside the priority queue, then I also want to add in the end. So I'll check in the end, and if the priority is still having size greater than 0, so if it is still having just one element, so I'll directly add it here so that I can get the final answer. Okay, so that is how I'll be doing it, and I can use a map, a data structure, hash map or something for showing the frequencies one by one, and I can insert every character if the character is occurring. So I can check, let's say from A to Z, I can check for all the characters that are occurring inside the string, and if the frequency of any character is greater than n plus 1 by 2, in that case I'll simply return the string as -1. Otherwise I will generate the answer as I've stated above. So what I will do is, I will now have a unordered map here. I'll have an unordered map, okay, of let's say character, because I'll be storing the character. For each character I'll be storing the frequency. So let's say I name it as map only. Okay, that will store the frequency. I also need a priority queue, so I'll have a priority queue. That will be nothing but a max heap. It will be a pair. So first part of the pair will consist of an integer. Second part will consist of the character. Why integer is stored in the first part? Because I'll give priority to the frequency first of all. Okay, so I'll name it as PQ, and then I also need a string answer. Initially I'll mark the answer as null. Okay, then what we'll do is we'll iterate through the string. So I also need to take out the size. So int n is equal to str.size. Okay, so I'll take out the size of the string. Okay, once I have the size of this, I'll say that int n is equal to size of the string. Okay, then I'll iterate through this string from the 0th index. So for like int I start from 0, I is lesser than n, then I'll do an I plus plus, and what we will do is we'll simply increment the frequency. So we'll say that map of the current is character plus plus. Okay, so we'll simply increment the frequency for each and every characters, and once we have done that, so we can iterate like how many characters we have. So we have just lowercase characters. So you can iterate from, let's say, A to Z, which will take 26 time only, constant time. So we can iterate from A to Z, okay, and we can check which characters are present. Okay, we can check which characters are present. So if it happens that if map.find, if I try to find the particular character, the current character inside my map, if it is not equal to map.end, okay, so if I have it inside my map, if it is occurring, so what do I want to do? I basically want to insert it inside the priority queue along with its frequency and the corresponding character, correct? So if I will have to check one thing more, if suppose the frequency of the current character, if it is greater than n plus 1 by 2, okay, if it is greater than n plus 1 by 2, in that case I can simply say that I should be returning a -1 string from here, indicating that the answer is not possible, because if there is any character inside the string that is occurring more than n plus 1 by 2 number of times, in that case I will not be able to generate a string which is not having any adjacent character as the same. Okay, otherwise what I will do is I'll simply push a pair. That is, first of all I'll push the frequency. I'll push the frequency of the character along with the character inside the priority queue one by one. Okay, and then I have our answer declared already above. So after that, what I will be doing is I'll be iterating through the priority queue one by one to store to update my answer. Okay, so what we will do here is we'll say that while the priority queue size, okay, is greater than 0, greater than equal to 2, if it is having 2 or more elements, then I can take the elements out. So first of all, what we will say here is we will say that first of all we'll take out the first pair. So it will be in form of pair comma like pair of int comma char only, because in the priority queue I have stored it like this. So let's say it is the first pair, so I'll do pq dot top. Okay, I'll take it out and then I'll pop it out as well. Okay, I'll pop it out simply out of the string. Okay, because I want the second pair as well. So I'll say that pair int comma char. Let's name it as p2 is equal to nothing but again pq dot top. When I do pq dot top, so I'll get the second most frequent element currently. Okay, I will again pop it out because I'll insert it after updating the frequency if it is greater than 0. Okay, so what I will do here is I'll say that okay, int the character 1, the first character is nothing but p dot second. Okay, first character is stored in p dot second. We can have it instead of int, we can have a char. Here also we can have a char. So char ch2 is equal to nothing but p dot p1, it would be, let's name it as p1. Okay, so it would be it would be p1 dot second, and character 2 will be nothing but p2 dot second, right? The second part of the second pair. Okay, so that's how I'll take the characters out. Okay, and I'll simply say that answer plus is equal to ch1 plus ch2. So I'll simply update my answer with these two characters. Okay, answer, whatever answer was there, plus the ch1 and ch2. Okay, once I've done this, so I also want the frequency, so I'll say that frequency 1 is equal to nothing but p1 dot first. Okay, and the frequency 2 is equal to p2 dot first, right? The first part is always of the pair is obviously containing the frequency, so I'll say that I'll update both the frequencies by 1. So I'll say frequency of 1 minus minus, because it will decrease by 1, and the frequency of the second character will also reduce by 1. Okay, so if it happens that the frequency of the first character, if it's still greater than 0, right, if the frequency of the first character that I had taken out, if it is still greater than 0, then I need to insert it back inside the priority queue. So I'll do what, I'll insert the frequency 1, okay, along with the character 1, along with the corresponding character. Okay, and I need to check the same thing, that if the frequency 2 of the character of the second character, if the frequency of the second character, if it is after updation, after reducing it by 1, if it is still greater than 0, so I need to insert this particular character again inside the string along with its frequency. So I will insert the frequency 2 in the map along with the second character. Okay, that is what I will do. And in the end, when I come out of the while loop, so I'll check that if it happens, right, if the priority queue, if the priority queue size okay is greater than 0, if it is still having an element, so I will say that answer plus is equal to pq dot top. If it is still having just single character left, so single character will be stored in the second part, so I'll add pq dot pq dot top dot second. I'll add this particular thing in my answer, and then I can simply return the answer over here. Now let us try and compile this code to see what happens. So we are getting several errors here. Okay, so frequency was not declared properly, and it says that enclose braces push. So I have declared the pair properly. Okay, let's see what is the error now. Okay, so we are not getting the same output here, right? We are getting a 0 output. Actually the output is 1, so we are making some mistake somewhere or the other. So let us try and check that out. So let's iterate through the code once again. So I have made a map. Okay, I have made a priority queue which will be consisting of the characters and their frequency. Initially I've made the answer as null. Okay, then I have done what? I have basically iterated through whole of the string, and I've incremented the frequency for each and every character. Then what we have done is we have iterated from A to Z for every character, and if the character, if I find that particular character, if it's not equal to map.end, if it is present inside the string, if it is present inside the map, okay, so if its frequency is greater than n plus 1 by 2, in that case I'm returning a -1. Otherwise I am pushing the character frequency along with the character. Okay, that is what I'm doing. Now I'll iterate. If the priority queue size is greater or equal to 2, then I'll take out the p1. In the p1 I'll take out the first character, in the p2 I'll take out the second character, and the character 1 will be p1 dot second, character 2 will be p2 dot second, and in the answer I will add it like this. So maybe this part is fine. Then first part will be the frequency will get updated by 1. If the frequency is still greater than 0, then I'll push the frequency of the character 1 and the character 2. Okay, and after that I'll insert this thing and I'll return the answer. Okay, so I am missing something normally. Let's check this out. Okay, so let me just print the answer so that we can see what mistake we are making. Okay, so in our string we are actually not able to build the answer, I think. Okay, so maybe what I could have done here is, let's say answer plus is equal to, first of all I add the ch1. Okay, then answer plus is equal to, let's say I add ch2 here. Let's say now we see what happens. Okay, now it's giving the same output expected. Let us now remove the comment. Let's compile it now to see if it works on the samples properly. So we are getting the same output on the samples. Let us try and submit this code as well. So you can easily observe that our solution was able to pass all the test cases. This was the solution. Now talking about the time complexity of this code. So the time complexity will be nothing but order of n log n. Okay, and the space complexity of this code will be nothing but order of n. Why order of n log n is the time complexity? Because heapify process for one time takes order of log n time, and there are n different elements of, like suppose there are n different characters, it will be n log n, and the space complexity will be order of n because we are storing all the characters inside the priority queue. In case if you understood, so make sure to hit the like button. Thank you. In this video, we will discuss the problem find median in a stream. So the problem says that we'll be given an input stream of n integers, and the task is to insert these into new streams and find the median of the streams. So basically what will happen here is we will be given the integers will be given to us one by one in form of a stream. So let's say if first of all we can get 1, okay, from the stream, then the median would be 1 itself. Suppose that after 1 we also get 3. So in that case you can see that the number of elements are even, so size becomes even. So if the size is even, then the median would be nothing but the middle element of the first half and the second half plus divided by 2. So that will be nothing but 1 plus 3 divided by 2, that will be nothing but 2 here. Okay, suppose I get the data as 1, then I get 3. After 3, let's say I get 2 as well. Okay, if I get 2 as well, so in this case the median would be nothing but the sorted answer. So the median would be nothing but 2 here, because 2 is the median is nothing but I have to write the data in sorted fashion, and whichever is the middle element, that is the median. Okay, suppose after that what I get is, after this I get 1, 3, 2, and then I get 7 as well. Okay, in this case when I get a 7 as well, so I can see that 1, 2, 3 and 7, so the median will be nothing but 2 plus 3, and that is coming out to be nothing but 2.5. After that, let's say I get another element. Let's say another element that I get is 5. So the 1, 3, 2, 7 and 5. So one by one I'll be getting the elements from the stream of integers. So when I get 5 as well, so if I write this in sorted fashion, so it will be 1, 2, 3, then 5 and then 7. So since the size is odd, so the median will be nothing but 3 here. Okay, we can observe this part. So one thing that we can do is, every time we get the integers, right, every time we get this, we get a particular data, so we always store the previous data in the array, and then what we do is we sort, we get the new data, we add it inside our array as well, and after that we simply sort, and then if the length is even, right, if the length is even, then the median would be nothing but the sum of the middle elements divided by 2. If the length is odd, then the answer will be just the middle element directly. The median will be the middle element. But if we do it using that way, so it will actually take a lot of time, right? Because every time if you are doing the median, so it will take n log n for each and every query. So for that we need some better data structure. We will look for some data structure that can help us to do it in a better time. So suppose if we have this particular data, suppose the currently we had 1, 3, 2, 7 and 5. Okay, suppose. So I wanted what? I wanted let's say, in fact, if we had 1, 3, 2 and 7, if suppose that we had this particular data 1, 3, 2 and 7. So what would be the sorted format? The sorted format would be 1, 2, 3 and 7. Okay, so if you consider it as a dividing line, as the midpoint, so I wanted what? From this part I wanted 2, and from some part I wanted 3. So there are two halves, right? From the first half, suppose there are two halves. Suppose this is the first half and this is the second half. So I can observe that from the first half of the array, I want what? From the first half of the array, I want nothing but the maximum element out of it. And from the second half of the array, I want the minimum element. So if I want the maximum element, suppose that I'm getting some data, and I can divide it into two branches, right? I can divide it into two branches. I can have the maximum, one part will consist of the maximum. So first half will consist of the maximum element in the first half, and another thing is I want the minimum element of the second half. So if I want maximum of the first half efficiently, and I want the minimum out of the second half efficiently, so which data structure comes to our mind? The data structure that comes to our mind is nothing but the max heap and the min heap, because using the max heap and the min heap in logarithmic of n time, in log n time, I can get the maximum element amongst a group of particular elements, and I can get the minimum element among a group of particular element, correct? If the element is, let's suppose that there is a top element, let's say x. Okay, so if the new elements that I'm getting, maybe if they are lesser than equal to x, then I can insert it into the max heap, because I want the elements to be like that in the max heap. And if the elements are greater, so I can insert them into the min heap. Okay, this is how I can do it. So one thing that we are sure about is that we want efficiently, what if we have if we consider the problem, if we divide the problem such that we consider it into two halves, the first half and the second half. So I want what? I don't want to completely sort it. I want the maximum element of the first half and the minimum element of the second half. If I have it, then I can probably answer. Now you will think that, okay, what if we have some random data? Suppose if we have data like this, if suppose we had 1, 2 and 3, so in that case how will we divide? So let's say if we had divided like that, so if suppose in the min heap, like if in the max heap 1 and 2 was stored and in the max heap 3 was stored, so in that case if one of the heaps is having greater size, then I will simply return this data. But let's also see quickly through the simulation now. So what will happen is, suppose we have the data like this, suppose we have 1, okay, first of all we insert 1. So currently we will have a max heap, okay, we will have a max heap and we will also have a min heap with us, okay. Then what we will do is, if we have 1, so first of all you insert 1. If the max is empty, then we can insert the element into the max heap, okay. After this, if someone will ask me that, okay, what is the like median, so I will immediately say that if it happens that the max heap is having greater size than the min heap, then the answer will be stored in the max heap. So I will simply say that for 1, the answer is going to be nothing but 1 only, okay, and that is very obvious. The median is going to be 1. Suppose 1 and after that I have 3 as well, okay, I have 3 as well. So suppose I inserted 3, another element 3. So if 3 is inserted, so since 3 is greater than the current top element, so I'll insert it into the min heap, okay, I'll insert it into the min heap. And now if someone will ask me the median, so I can see that the number of elements are what? The number of elements are even, and when the number of elements are even, so I can say that when will the number of elements become even? The number of elements will become even when both of the min heap and the max heap are having the same size. If both of them are having the same size, then I can take out the top element of the max heap, that will be the maximum element in the left half, and the min heap will consist of the minimum element in the right half. So I can take the top elements out of both, and then 1 plus 3 divided by 2, so that will give me nothing but 2 here. Perfect. After this, suppose I insert another element, let's say I insert another element as 2 only, okay. If I insert 2, so if I see with the compared with the top element of the max heap, so currently the top element of the max heap is just 1. If the top element is 1, in that case what I will be doing is, I will simply insert it into the min heap, because the top element is lesser, because the top element is 1 and the current element that I want to insert is 2. So I'll insert it in the min heap, okay, not in the max heap. So I've inserted 2. Now if someone will ask me that, okay, what is the median? So the median for this case would be nothing but 2, right? Why? Because 2 is the median. You can see 1, 2 and 3, 2 is the median actually. So if again, if someone will ask, so we will say that if the max heap size is greater than min heap size, then the top element would be the answer. But actually the max heap size is not greater, right? Because there are odd number of elements. So if the min heap size is greater, then I'll simply return here 2, okay. After that, let's suppose I insert 1, 3 and 2 was there. Suppose that after this I insert 8 as well, okay. So if I insert 8, so you will say that, okay, 1 is here. So I'll like the current top element is not greater than 8. So I will only insert the lesser elements here, okay, in the left half. So I'll insert 8 in the min heap. Once I insert 8 into the min heap, so again if you check, so what are the elements? Like the elements in the arranged order would be 1, 2, 3 and 8. And the median would be nothing but 2 plus 3, that is nothing but 2.5. Okay, 2 plus 3 divided by 2, that will be 2.5 only. But how will I get this? Because if you will observe, so if I check, so the sizes, so if I check the sizes, so in that case I can observe that the min heap is having more size compared to the max heap. So in that case I'll return the minimum element of the min heap, so that will be nothing but 2, but actually the answer was 2.5. So in this case what I need to observe is, I need to observe one thing, that I need to balance out. Like the difference between the min heap and the max heap, that's the difference between the size of the min heap and the size of the max heap should be not more than 1. If the more than one element, if more than, like if the difference between the size of the max heap and the min heap is greater than 1, in that case I need to balance both of them. Okay, so what I will do is, I'll take out the minimum element of this min heap, and push it here, push it in the max heap, and I'll remove it from the min heap. Okay, now you can see that it gets balanced. And if I will see, so now I can check easily. So max heap size is equal to the min heap size. So in that case the answer would be nothing but the maximum element of the max heap and the minimum element of the min heap. So that will be nothing but 2 plus 3 divided by 2. So this will be nothing but, you can say 2.5 will be the answer for this case. Okay, after this, suppose I get another element, as let's say 1. So if 1 3 2, or let's say I get another element as 2 only. Okay, so if I get another element as 2, so if the element 2 is there, so 2 is what? 2 is lesser than equal to 2 only. So current element is like the top element is greater than equal to 2 only, because the current element 2 is like, if I want to insert 2, so 2 is what? The current element, top element is also 2. So top is greater or equal to 2 only. So I'll insert it inside the max heap, let's say. Okay, if I insert it inside the max heap, then do I need to perform the balancing again? No, because the size just differs by 1. If the size differs by 1, so whichever is having the greater size, its top element I'll print. So now max heap is having the greater size, so I'll insert, like I'll simply return 2, because 1 2 2 and 3 and 8, if I consider this example, so since the length is odd, so this is the first half, second half, and 2 is there in the middle, right? So that's why the median would be 2 for this particular part. Okay, after that, let's say if I insert another one, so let's say if I have 1 3 2 8 2 and then 1, so if I insert 1 will come out to be here. Now I need to perform the balancing part. Every time after every insertion, I need to balance it up. I don't need to directly check the size. So what will I say? I'll say that, okay, whichever is the top element of the max heap, I'll insert it into the main heap and I'll delete it from the max heap. So I'll insert 2 and 1 is standing here. Okay, 1 is here. Now what happens here? If I observe, so the size is obviously the same, because the data is like this. It is like 1 1 2 2 3 and 8. So the median is what? This 2 plus 2 is the median. So you can observe, if the size of the main heap and the max heap is same, so that means the stream is of even length, and in that case I have to get the maximum element from the left half and the minimum element of the right half. So that will be nothing but 2 plus 2 divided by 2. So the answer would be 2 here. So that is why we are balancing it here. And if you will observe, since we are using the priority queue, or like we are using the min heap and the max heap, so for every query, we are able to adjust very quickly, right? So it will take logarithmic of n time, which is very, very efficient compared to the earlier approach when we were sorting the complete streams as a whole. Now, because in this case, when we have min heap and max heap, so the computations become much more easier at each and every step. So that is why we are using min heap and max heap concept here. Let us quickly look at the code implementation of it. Since the writing the code can be a bit larger, so that's why just to save some time, I have written it already. So we will have what? We'll declare first of all a max heap, then we'll declare a min heap. Okay, after that, we will perform the insertion operation. So if the max heap is empty, or if the top of the max heap, if the top element of the max heap is greater or equal to x, in that case, as I said, I'll insert it in the left part, so left half of the array. So basically, I'll insert it into the max heap. Otherwise, if the element is greater than x, like if the current element x is greater than the top element of the max heap, so I'll insert it into the second half because it is larger part, so I'll insert it into the min heap. And after every insertion, as I said, I'll perform the balance operation, right? So I'll balance the heap. So I'll take out the difference, the absolute difference. Like I'll see what is the difference between the size of the min heap and the max heap. So if the size of the min heap and the max heap, if it is greater than 1, right? If the difference between the sizes of the min heap and the max heap, it is greater than 1, so that means I need to perform the balancing. So if the size of the max heap is greater than the size of the min heap, okay, so in that case, what will I do? I'll simply inside the, like if the max heap is having more elements compared to the min heap, so in that case, I'll simply say that I will transfer the max heap, like maximum element of the max heap, into the min heap, and I'll delete that particular element from the max heap. Otherwise, if the min heap is if the min heap is having more number of elements compared to the max heap, and the difference is greater than 1, difference of the size is greater than 1, in that case, inside the max heap, I'll insert the top element of the min heap, I'll insert the minimum element of the min heap, and I'll simply pop this min heap out. Like I'll pop the minimum element out. If I want to get the median, so if it happens that the size of the min heap is equal to the size of the max heap, in that case, I'll simply return nothing but the, if the size is even. So in that case, I want the maximum element of the left half plus the minimum element of the right half divided by 2. Okay, that is what I will do. Otherwise, the min heap and the max heap is already balanced. So if the max heap size is greater than the min heap size, so that means that the current stream size is odd. So in that case, I'll simply return the max heap top, because the max heap top will consist of the current median element. Okay, otherwise, if the min heap is greater, if the min heap is just having greater size compared to the max heap, in that case, I'll return the min heap top. This is how I'm doing this particular problem. So for doing this, since we are using priority queue, so the overall approach for every query, the answer will be done in very, very efficient time. So in case if you understood this particular explanation, so make sure to hit the like button and comment on understood as well. Thank you.